great to see all of you here. And you made the right choice. It was a hard choice in this time slot, I know. And I'm very thankful that you all came here. So welcome to the reasonable overview of Java 9 and what you should think of it. And before I start speaking to you about Java 9, let's talk about myself a little bit so you have some amount of trust that I'm not just coming up with stuff out of thin air. So my name is Oleg, and I come from Estonia. I work for a company called Zero Turnaround, which is a company that does tools for Java developers. So if you are Java developers, please go and check them out. They're amazing tools. I promise you people love us. So my employer will be happy, and they will send me to meet more people. I'm a developer advocate as of right now, which means my main responsibility is to care about community of Java developers all over the world, kind of travel, talk to people, try to figure out what the problems is, and maybe advice from my past experience. Before that, I was a Java developer for approximately 8 years, so I've done my share of coding. I'm one of the founders of, leaders of a Virtual Jack, which is an online Java user group. So if you're not a member of that, join. It's an excellent, all the sessions are online, so you can learn without leaving the comfort of your own home. If you have any questions during this presentation or afterwards, find me on Twitter. I'll be happy to chat with you. So with all that compulsory stuff out of the way, let's talk about Java 9. And this is obviously not the first session here about Java 9. And I expect like almost all of you heard something or seen something about Java 9 because it's such a great release. Before me, Simon Ritter was on stage, and he took a look about on Java 9, like what goes inside from the Java enhancement proposals, what topics are in. So we're going to take a look a little bit differently, what a developer would expect from that, and is this release actually good for developers, or maybe it's not as great as we could wish for. So let's start. Do you know what's a code name for Java 9? You don't, because there is no official code names, but in one of the main projects in Java 10 that we know of is the value types called Valhalla, right? So, and obviously Java 9 would be the road to Valhalla, so it would be Java 9, the Fury Road. And as we will see at the end of the presentation, we will almost die on this road to Java 10. Now, this presentation, I come from Estonia. It's a dark and cold country, so I have a very dark and cold sense of humor. This presentation will contain sarcasms and opinion. If you think I said something obnoxious, throw a frisbee at me. Don't hit the laptop, because the setup will waste precious time. If you hit me, nothing, don't worry about that, bruises heal. We have tons of content, so I will be speaking fast, and it's gonna be a little bit hard, but like all true fans of metal would expect, and I hope you will enjoy it. So, without further ado, let's talk about Java 9. One of the most important things that you have to know about Java 9 is that the release date is set on September 21st. This is not the first release date that was announced. Somewhere back in the past, in 2011, somewhere at Java 1, Oracle said that, well, we will release, or we plan to release Java 9 in 2016. And then they postponed it, and postponed it, and postponed it again. And now, September 21st is when we expect that. And probably things are on track. So what we're talking about now is kind of almost the finished state of Java 9. Allegedly, and if you follow the information of the official Java 9 website, today, June 22nd, is the release date of the initial release candidate, right? So when they release that, maybe it will be in a couple of days, probably this binary would set in stone. So there will be minor improvements, but allegedly nothing much should change, because that's what release candidates are. We will see. Tons of stuff has come into Java 9. Obviously, it's been a couple of years. Now, one way to learn all about that is to read the JEPs, right? And there are tons of them. And obviously, no one does that. No normal developers that I know of go through all the JEPs in the list and do that. Another way to see what's inside is to follow mailing lists. And mailing lists, they contain discussions. not only you get the information about what's inside, but you also get motivation and everything. And it's great fun to look at that. There are some hardcore battles happening in there, opinions clash. People, they don't call names on each other, but they are pretty agitated there. We are developers. What we do, we stare at the laptop screen all day long. So we're going to take a very practical approach. And we will download the latest Java release, Java 9 release, and we will see what's inside. Who's on board with that? Yay, we should. So at this point of time, I will move into the different mode, and I will show you what I will show you. I will show you my command line terminal. You can see my screen, right? Excellent. And you can see it's pretty. Is it pretty? Font is nice. So JShell. What is a JShell? It's a REPL. It's a read, eval, print loop. What is good for? You can run Java statements and expressions in that and get the results immediately. There is cool things. You don't have to do certain things. So if I type int a equals 1, it works. It prints me back the value of the variable that I just declared. I didn't type the semicolon. So finally, Java is like half a step towards Groovy and other modern languages. You can omit semicolons. And we will look at the API improvements in Java 9. Because API is what developers do all day long, right? So there are other features, but they might be not as important or influential to day-to-day developers' life. The best thing in Java 9 improvement of API are the collection literals. Who would like to see collection literals in Java 9? Too bad, there are no collection literals. It's Java after all. There are factory methods. So what you can do, you can type stuff like list off and give the parameters here, and you will get back a list, which is a nice collection method, a factor method. You easily create a collection out of the elements. You can also do that with sets, set of element or multiple elements, and maps as well. You just give the pairs of keys and values and get back the results. What is good about that? Because it unclutters your code. You never need to do that double braces trick again, because you have a nice API for that. What is also good that the implementations of those methods, of those classes, is extremely efficient, right? So if you think, if I do this, list of 1 get class, who thinks it will be an array list? Who thinks it will be a linked list? It's neither. First, it's an immutable collection, and it's also a list of 1 element. Because we know it's immutable and contains just 1 element, for the most efficient access, this element is packed into a field in that class. So accessing that, you just remove 1 redirect. You don't read the array of elements. You just go directly to the element. And it's pretty great. And you can give multiple arguments to that, varargs and up to 10 arguments for the classes, and it's perfect. The next most exciting API here is the additions to optional. Who of you is currently on Java 8? Pretty much. Who is on Java 7? You ought to upgrade. The end of life for Java 8 is this September as well. So you are almost 2 versions behind. If you are on Java 6 or beyond that, I feel a little bit sorry for you, but I hope they pay you a lot of money. So optional. Optional is a container for values. It can contain a value or be empty. So you can eliminate the nulls and null checks from your API. What you can do, and you can do that in Java 8 as well. In Java 9, one of the most welcome things is that now you can turn an optional into a stream, right? And a stream is great because on the stream you can have all the stream API. The question is now, why would you want to do that? The answer is very simple. If you call a map on an optional and say you apply a function, it's eager. You immediately evaluate that on an optional and you pass it ahead, right? If you call it on a stream, the map and all the non-terminal function invocations on a stream are lazy. So if we turn it into a stream first, and then we map it, then we get back not the actual value, but the pipeline implementation. So the function is not evaluated. So your code can potentially execute less statements and be more efficient. And it's pretty great. Another thing on optional is optional, say, of 1, of null, say, empty. And you can do an OR, which takes a supplier of another optional, of devox. rocks. Pretty great. So you don't have to specify even more null checks in that. You don't have to ever specify and access the optional is present. If you find an optional is present code in your code base, that's probably a code smell. You shouldn't do that. Additionally, on top of the optional, there are things like if present on else, if that can take two runnables and execute runnables based on the condition if there is something on the optional or not. And you can replace all the ifs in your code base with optional. And that's pretty great. Another thing is streams. On a stream, what you have now, you have the way to operate on infinite streams way better. What it is the take while and drop while. Say if we have an int range, no, it's in stream range 1 to 10. What you can say drop while. You can see that JShell comes with an completion. So, and you drop while, say x less than 5, and then you map something. For all the elements, you print system out println x. You can see that API is not the most convenient because to type in the JShell. What don't you like? Bad return time. It's not map, it's for each. And stuff like that. So you can see the part of the code is dropped. The take while moves the same way. You take the elements until the condition is done. So if you have an infinite stream, it's very easy. You just take all the elements that you need and you skip the rest. There are improvements to date and time. They're smaller, and for the sake of time and brevity, I will not show you on the JShell. What you can do, basically, you can have a duration now. So, and you can convert that duration like a time chunk into various units. And you also have the way to have a stream of all the dates between two kind of dates, which is excellent if you do any kind of processing. Who does concurrency? Who's interested in concurrency? 4 people. More people should be interested in concurrency because I'm interested in that and I'm on stage, so you're kind of here. What we can have now is improvements to the completable future. A completable future is a class that, what do we have? Let's say completable future of string, and we call it F. And it's a new completable future. And semicolon is expected. Weird. No? That's true. We're not groovy here. Anyway, future. Thank you. See, that's why I'm a developer advocate. They don't trust me with code anymore. So what you can do with future now, you can copy that. So a completable future represents a result of a computation that will happen in the future. And it's very convenient if you want to have an asynchronous API. You just return a completable future to a client, and they just wait on it, or they check if it's done or not. And you will complete that at your time. Now, before that, it was very inconvenient, because your client would have the actual reference to your future, and they will be able to complete that. Probably it's not what you want. You want to be in control, so now the copy is a defensive copy. So if I just do 43 complete and give it a thing, so now what 43 is done is true, and it's excellent, but what is that? My excellent future, it's not done. And it's marvelous. So now you're way safer if you do asynchronous API things. They also added timeouts and delays into the computable future, and it works pretty good. Another thing is the process management API. So I think it goes like process handle. Excellent, PH. And we have process handle. There is new again. I'm bad with this new stuff. Come on, come here. No. New. Don't judge me. I think it's current, and it's not even new. Let me check. Yeah, it's not new. Oh, come on, guys. You should have spotted that. Process handle, PH, excellent. Now what we can do on this PH, if you do any kind of sub-processing, or if you refer to processes by the PID, right, it's great because you can have the PID number out of that, and then you can do all kind of cool things. You can get info, not the PID, but PH, of course. You get the info, and you can get the command line that was used to start your process, where you can get the arguments. And it's exciting because that works on all the platforms that Java supports out of the box consistently in the same fashion, which is amazing, pretty amazing. There are other API improvements. I want to talk about language improvements a little bit. What will happen if I type this? An underscore equals 1. Correct answer is that underscore is now a reserved keyword. And the reason for that is that when somewhere in the future, probably it will be used to refer to unused arguments in lambda expressions. If you have a lambda of 4 parameters, but you only use one, you can just name all the other underscores and it's going to be fine. So how to overcome that? If you use lambda underscores in your code, use 2 underscores. Who thinks this will work? 2 people. Well, it works. Interesting. I thought there will be a type declaration. Great, but this is what it is. There is semantic versioning, which changed. Now, if you have runtime version, you get back the an object, and then you can access the major, minor, and so on. You can have the private methods in interfaces. You also have, what do you have? You can use effectively final variables in the try with try finally block, in the try with resources, excellent, block, which is great because it unclutters your code. And the last bit that I will not type because I'm bad at typing, as we see. There is a thing now, if you use property files and if you use the UTF-8, if you have any letters that are accented, which is very dear to me because my surname starts with an accent letter, so it's great. Now there is a way to read property files in UTF-8. And it's fantastic, right? So all we need to do is have the property resource bundle and then the handle get object and give it a parameter. And we get in response back the UTF-8 string, which is amazing. None of the other property methods are working like that yet, but hopefully it's a step forward, and this is excellent. So these has been the API improvements. Let's unmirror this and go back to the presentation. It sounds pretty exciting. I'm very excited to see the API improvements here. One more thing that is, all that API, if you want to read about that, now the Java doc of Java 9 is HTML5 modern and it's searchable, which the thing that I caught on the previous Simon's Reader presentation. So you actually have a way to search for those things easily. And this is great, and it works. Indeed, those API make the life of developers better. Maybe not every one of you will use those all the time, but just knowing that they're should warm your hearts and know that the platform moves forward. Now, JShell in itself, obviously it's a toy. It just, like, you run one statement lines, and it's not that great. What you write your code in, you use an IDE. An IDE is support for Java 9 exists. And as a reasonable developer myself, I use IntelliJ IDEA, obviously. If you use others, they also have the support for Java 9. Somebody less, somebody more. Who uses Eclipse? Who uses NetBeans? OK, so the thing is, I'm running currently one of the surveys, and later I will report back the results in the form of great PDF. The survey aim is to learn why developers use the tools they use. So if you take a moment after that, or somewhere in a break, or in the upcoming week, and fill the survey, it will take just a couple of times, it would be amazing, especially if you use Eclipse or NetBeans. If you use IntelliJ IDEA, I personally know why you use that. It's a great IDE. So it works. Now, you start using those API in your IDE. What happens? You stuck on the module system, right? And this is the big elephant in the room. The module system consists of like 7 JEPs, and it's taken so much time to actually materialize in the thing. What does it do? It was supposed to divide the JDK into smaller modules, so you actually only use the stuff that you need to use. You don't have the Corba classes in your JDK process, Java process by default anymore. You have to add that manually. Who uses Corba? Excellent. Who knows what Corba stands for? Okay, poor people. Excellent. If you talk about the modules, why is it good? It's because there are, like, when we talk about systems, large systems, we talk about in this way. We draw diagrams of boxes and say, oh, now the payment processing module will talk to, not module, component, will talk to the payment API thing, and there are microservices and all stuff. And it's great because it's very easy to understand on a human level. It's really harder to understand on the code level, and sometimes things that are good for the platform, like the module system, are not great for the application code. Not surprisingly, the module system has found some backlash. People are not happy. There are some module systems in existence, like OSGI, JBoss modules, and they all express their opinions. If you haven't read the Jigsaw mailing list, it's full of great gems, and you should go and educate yourself on that. And it's also a fun read. So who thinks modules are exciting? So I have great news. You are clearly very suitable for the position of an architect. And there are also a little bit of bad news. In the room too, currently, Arun Gupta talks about container orchestration. That talk might be more suitable for you. Modules are not that exciting. The syntax is what developers will see the most. And it consists of a bunch of new keywords added to Java language. And they're restricted keywords. What basically it does, you have modules, and they organize themselves into a graph, into a direct graph of dependencies. A module can require a different module, and that means that it specifies the intent to use the classes of that module. The JVM will see that connection and will make the best to provide those classes to them. And if you don't require a module, you will not get access to those classes. If you want to offer some API to another module, like to be a dependency to something, you export certain packages, and you say those packages are not public, and somebody can use those packages and classes in those packages. If you don't want to do that, you can export some packages to specific modules. You can say, oh, now my user info store module will have access to my user different module. But no other modules will have that. So you control the visibility rules. That helps you with the integrity of your application. That helps you with the encapsulation of your code. And it's very great. You can also open the module to everyone. Absolutely everyone using the opens keyword. And that will give access not only to public methods and classes and fields in the packages, but just everything in that module will be open for manipulation. A good summary of what it all means is this table, or you can read that on the blog of Nikolai Paralog, or in his book. But basically, export, you mean all code can access public members. Open means that everyone can access everything. On top of that, if you just don't want to specify that stuff in the module info files that go into the jar files, you can add the command line arguments. And you can add exports on the command line after the fact. You will use that also to, since JDK itself is modularized, you will use add exports to say, oh, my code will really, really want to access that particular thing. And you can also specify which modules you want in your image in your runtime. And this is where we go to the IDE, because we love IDEs. Just to see. It works in the IDE, and it works on my machine. So hopefully that's enough for everyone. You can see that, excellent. Can you see that? You can see that. So we have a small project here, which consists of 2 modules. It's a MAVEN project. So there is a hint that it actually works with MAVEN. And you use the correct versions of the plugins, up to date. You use the correct version of some dependencies. It builds. Now we have 2 modules. The module 2 requires module 1. It wants to access classes from the module 1. And the module 1 exports classes to anyone. Now, there are a couple ways to call a method in Java. So you can use just instantiate the class, call a method using the bytecode. You will see that it actually works, right? It calls a method, and this is implementation of the superclass in a package that is internal, that is not exported, and it works. Now, if I do this, I will use reflection, because the reflection is cool, right? So I will say that I want to, what's that method? I want to access that method through reflection at runtime. If I use this, unfortunately, just the export keyword in the module does not allow the reflection access. This is used to encourage strong encapsulation, a better encapsulation. So this is great. Who have heard of method handles? Right? This is kind of reflection 2.0 API for accessing methods. Surprisingly, if I just do the method handles and call the same method, I would expect it to work as the reflection, but it's not. It allows the access through method handles, which is very confusing. On top of that, since we're here, and this obviously works in the IDE, one thing that I want to talk about is the unsafe. Who uses the unsafe? Great. Either I don't see any hands, or you are very responsible developers. So if I just uncomment my code here, and I will import stuff, and I will import my unsafe, you can see that my IDE gives me a suggestion that I need to add the requirement to require the module. And I will do that. Now we have the requires JDK unsupported thing here. And there were many talks about how they want to remove the unsafe from Java 9, but you can see the unsafe is still there. So you're good to go. They also copied that into internal packages for their personal use, the JDK version, but the old unsafe is still here. So we are good to go for at least 2 to 3 years, or judging by the past performance of the releases, maybe 4 or 5 years. Excellent stuff, the unsafe. We can do manipulation of stuff more. Let's go back to the presentation. Let's go back to the presentation on Mirror, Keynote. So when we talk about modules, one thing that you want to remember is that modules are about the architecting your app, right? And you know that whatever goes wrong, developers will be the ones to fix the code and be blamed for the estimates and deadlines, everything, because developers are the only ones who can fix things. So when you think of modules, think of this picture and think about who here is a developer and who here is the architect or somebody else, a team lead. I judge from my experience that the developer is the bottom one here, very unsafe. On the topic of the reflection, you know that how you can say like a field or a method set accessible, right, and make it public. So now with the module system, it doesn't work like that easy anymore. But what I also wanted to ask you, do you know that there is a getter that is called method is accessible, and it returns you a Boolean? What do you think it returns? Who thinks it returns if the method is accessible, like is it public or not? Who thinks it returns something else? No, approximately equal amount of people. So what actually it returns whether you called set accessible true previously or not. It actually doesn't query the visibility of the method. And this is very strange, and because, well, the JDK developers are actually very smart people. So now they're adding the check accessible method, which is way better because check accessible works in the module systems, in the module pass as well. And they deprecate is accessible because that naming just wasn't making any sense. If you don't want to do the modules, you can just drop your jars into your class pass. If you use module pass and modules, they will become an automatic modules with the name derived from the jar file. The automatic module exports everything to everyone. Well done. So you can just use that. And the summary of what it is, if you use the class pass mode, which is still present, and it's a great mode, we've been with that forever, and it works, everything gets into the unnamed module. If you use module pass with modular jars or non-modular jars, it's automatic modules. So talking about class pass, the one thing that were very controversial is that the migration pass on the module system is crazy complicated for the applications, real-life applications. So they added the kill switch, which initially was called the permit illegal access, and then they renamed that into the illegal access equals a level of things. By default, it's a permit, which means that when you run that Java 9 with the class pass mode and you run your code, it will issue you one warning if you violate any encapsulation rules, but it will allow you to do anything you want. And this is great because, actually pretty dope, because it means the class pass can live now basically forever or until they will cut it off. So with that in mind, the migration strategy to Java 9 modules is very simple. Don't do that first. Wait for your dependencies to move to the Java 9 modules to modularize themselves, and then you can use them. If you modularize your code first, you will end up with automatic modules. The file name for those modules will determine the module name. You will use that module name in your module info files to require them, and then they will release the proper modular jars, and they will probably change a different name. So it's going to be a pain to migrate twice. Don't do that. Wait, and then migrate and modularize yourself. You can be pretty happy on the class pass for a long time. After all, 20 years of class pass, and we're still here. Now, what else? We have modules, we have the jar files. How do we get those jar files from the source files? We compile them. If you've seen any Java 9 modules presentation, they do that with Javac. Nobody I know, no developer I know compiles their code with Javac. They use the build tool. Let's talk about MAVEN. MAVEN in Java 9 situation is a little bit so-and-so currently. Because it's complicated, MAVEN has to package your stuff. There are plugins which are external dependencies. It has to process your class files. Some things work, some things do not work. Good thing is that we are not yet at the release date. So by September, allegedly, they will be able to fix everything. If you're using Gradle, you are in a way better situation. Gradle typically releases fixes way more often than once, twice a year. So Gradle supports a little bit more. And with a more modern architecture of the build tool itself, it's easier for them to do that. With MAVEN, important things are that the compilation works, making jar files works, tests work, everything works what you need except like pesky static code analysis things and packaging resources and shadowing classes into your own jar. Those things might not work, or obfuscation if you do that, this and that. Hopefully it will get way better once the ASM, the library that does the bytecode manipulation, everyone depends on, when they release the version that is capable of processing Java 9 class files, everyone will upgrade and the situation will get better. But until now, it's hard to say if that works or not. So I did the tests. I have a small project called ZTZip, which is a zip archive utility processing thing. Not mine personally, but I contributed that a little bit. With Java 9, it builds, and it runs all the tests, and it's absolutely perfect. And you can even set the target level and source level of the code to Java 9 and use the features. And it's perfect, and it works with MAVEN. If you're not particularly often deal with creating small libraries consisting of 4 classes, then you probably need a different example. Let's look at the Pit Clinic app for Spring. Who uses Spring? Good. It's a choice that a reasonable developer would do. If you just try to build a Spring Pet Clinic app, and I used not the most outdated version, but something reasonably 2017 with Spring Boot 1.51 something, then at first you will get the issues with the main plugins like Kobitura and some plugin that packages the resources, the CSS files and images into a single sprite and a single file. So since those are not exactly essential to the compilation and running, I just deleted that from the POM file. Let's be sure. So I run this kind of shortened build. What do I get? I get an exception. And it doesn't work. And it's because the jar file, the jar plugin is out of date. Because the Spring Boot plugin, which was released a couple of weeks or months ago, right? It didn't know yet that it has to support all that stuff. So if you just want to drop in your existing code base into the Java 9 environment, you will need to upgrade the dependencies and the frameworks. So, okay, I said, what if we built on Java 8, because it builds on Java 8, and just run it on Java 9, right? This is supposed to work. Afterwards, backward compatibility is what Java is known for. And what we get obviously the access violation thing. Surprisingly, that was on build, Java 9 build 174, which was the latest release built on the download network Yes, as of yesterday. I think maybe today as well, but maybe they released something else. Okay, the access violation, what we need to do, we need to allow the illegal access. We use the permit illegal access because the illegal --illegal access equals permit is not yet merged into OpenJDK, and we run this. Who thinks it works? Who thinks it doesn't work? Who doesn't care? Good. It doesn't work. It doesn't work. What it requires some classes that are not in the default image for Java anymore, and those are for XML bindings. This is the Java EE API, and what you need to do, you need to slap it, add modules, command line parameter to the process to actually make the image that will use that module. So what we do now, we add modules with a fascinating name of umbrella module java.ace.ee, which looks surprisingly like an Estonian website hiding a Swedish website hosting Java. But that's the name. The name is hard. Naming is hard. Who thinks it works? Yeah, it works. Of course it works after 4 steps. The one thing is, remember the plugins that we disabled, the Kobitura and the resource packaging. Since it didn't package the resources now, well, the CSS was gone. So it was a very ugly application. But that's not the fault of the application. And it works now. So you can make your projects run on Java 9 as of now. It requires some tinkering. And please, if you have half an hour spare, try to do that. You will learn a lot. It will be painful, but you will be able to provide some feedback, and it's not yet super late. Let's talk about another feature. We have 12 minutes left. The multi-release jars, which is a great feature in Java 9. What you can do now, you can package multiple versions of the same class inside a single jar. And then the JVM will decide which version it tries to access when you say, oh, please load my class. And it will look at itself and say, oh, I'm Java 9. And I will go into the MAVEN versions 9 folder and try to locate classes from there. Obviously, if you run on something older, you will access the class from its normal location. Java 9, if it doesn't find the class in its predefined location, it will fall back to that, and it works great. If you are a library author and you want to ship a single executable for all the versions of Java there are, but you use different API, like for example, in some classes you will be able to, in Java 9 classes, you will be able to use those fancy collection literals. You can do that. And also you can prepare for the future and package the classes for the later releases of Java. For example, this is a perfect place to hide the code that will steal credit card numbers under the 10th version of Java. When they release that, the code will snip into action, and you will quickly become rich, and also the police will be taking interest in you, probably. So probably you shouldn't do that. It's a great feature. If you really have a use case for that, and you know you have a use case for that, do that. Otherwise, don't. The caveat with that is that no build tool as of now yet build normal multi-release jars in a standard way. At least MAVEN doesn't do that for sure. So you have to invent workarounds and stuff. And it's kind of sad. Another thing is the memory and additions to the garbage collection. Now the G1 GC will be default. What it means for you as developers. If you have this image of how the Java heap operates, right? You have multiple generations. You have the young generation where the objects are allocated, then they're promoted, then they are promoted again and stay there forever. Sometimes you work delay. If you have this, you know that the rationale for that was that garbage collecting from the whole heap, which is large, is long. It takes time. So you want to separate those into smaller buckets. The problem with that approach is that when you have a very large heap, those buckets are also large. So when you need to traverse that and garbage collect the memory there, it will still take time. So you'll get the pauses from the garbage collection, which doesn't improve your latency at all. The answer to that is the G1 GC. It's a regionalized garbage collection. Instead of having like 3 regions, it has a ton of them, but they're small. They're also, sometimes they're hidden and hold new objects. Sometimes they're used for the old generation of survivor space. What is great about that is that when you do a garbage collection, in the old generation at least, you can say, I would like to have my garbage collection pause at most 200 milliseconds. And the garbage collection will say, OK, I get 200 milliseconds. I know that I will be able to empty 3 blocks of old generation space. So it will reclaim the space 3 chunks at a time. So it can tune itself, and depending on the usage of your application, it can say and kind of confirm to those suggestions how much time can it take. So you will get a low latency garbage collection. You will not get all the pauses there. It's great for performance, allegedly. This slide comes from a blog post of Oleg S, who is currently at Red Hat, and before that he was an OpenJDK developer at Oracle, and he's a benchmarking czar, and he knows a lot about performance. What he says is that here's how the serial garbage collection works. Everything was stop the world. Now the current Java 8 garbage collection implementation is concurrent mark sweep. What it does, the orange areas are stop the world, the green ones run concurrently. It is allegedly, it doesn't compact the old generation on the right there, so it can get the fragmentation issues and then stop the world for the whole garbage collection. Now, the G1 GC still has the pauses in the young generation. You don't get anywhere from that. And it still has a very small and adjustable pause in the old garbage collection. But it's very adjustable pause. The trade-off for that is that it has to do more work concurrently with your application. So allegedly, the impact of running with G1 GC is that it can take up to, like, say, 8 or 10% of your CPU time. So you get a smaller maximum throughput. It balances off with having smaller pauses, so you can still do the same amount of work, but it's something that you should be aware of. Obviously, you can add the tunit and everything. And if you want to know more about garbage collection, I can recommend listening to the sessions by Kirk Pepperdine. I have a link to a very recent one of him. And then you will know a lot about how the actual garbage collection G1 GC works, how to tune it, where the logs are, and everything. The next thing on that is the instrumentation API and Java agents. Why should developer care about that? Because most of the APMs, most of the sophisticated tools that will do the monitoring for you or do something spectacular with your Java process and transform the classes will be the Java agents. For the long time, the Java 19 wanted to disable the dynamic attach of Java agents to a running JVM process, and in the end, they didn't do that. So you can still have your cluster of applications running, and then you can attach one Java agent to a machine and, I don't know, debug or profile what's happening there. One thing that with that is prohibited now is the self-attach from the method, from the code. So a process cannot dynamically attach a Java agent to itself. What do you have to do to overcome that? Well, you have to spin a sub-process to attach the Java agent to your parent process, which sounds like cumbersome, but now with the great new process management API, you're kind of good to go. Also, another addition to the Java agents APIs is, not the APIs, how it works, is that now a single jar file can work as an application and the Java agent itself. So you can just ship a single Java jar file, and when you run with Java 9, it can start the Java agent from that jar file and then start the application from the same file, which is great if you don't actually control that much how you run the code. If you just throw your jar into the cloud and then hope it works, you are a little bit better. Well, that was fairly interesting, right? Java agents. Things that didn't get into Java 9. We talked about how we want to have the JSON processing in the standard library. Didn't happen. Makes hipsters sad and angry. The advice here is very simple. Use the library of your choosing. There are tons of them. It's not that hard, and it's very easy. About web applications now, Java 9 supports HTTP 2 client out of the box. It offers you the Fluent API to create requests and everything, and it's pretty great. The only thing is that it sits in the incubator. So you have to add that module. It's not available for you by default if you just run Java. The incubator was, no, kind of, I don't want to say the bad things about that because it's a lot of work, but it's kind of belly flop as well. Because they wanted that to have a platform, the incubator, where they would put the experimental but stable, more or less stable API, and they will promote that to different modules. Currently, the only thing in the incubator is the HTTP2 client, which was supposed to be in the main library. So, but you can use that, and it actually works pretty great. If you're not convinced that you should upgrade to Java 9 immediately, there are some performance improvements, most notably for the strings and how the JVM handles strings. One is to have the more compact representation of the strings, shrinking how much space they take on the heap, and it's marvelous. Another one is that when you concatenate the strings, which is allegedly one of very frequent operations that Java code does, the Java will emit the invoke dynamic method calls, which can be optimized further and further, much better at runtime. So this is great, and it gives you additional motivation to upgrade to Java 9. Yeah, there could be pains, and there could be surprising things, and it could be hard, and it's an unknown, and this is the first release of Java that breaks backward compatibility, or promised to break backward compatibility up to the very late moment in the release cycle significantly. And still, you get a lot of stuff in there. It's faster it can run with less garbage collection pauses. It gives you new API, and you are strongly encouraged to upgrade or at least try and test how it works on your code. You will feel a lot of time that you don't really understand what's happening or why is it happening, because there are things that, well, happen for the reasons, the trade-offs that you are not aware of. So here's a simple advice. Things that you don't want to touch in your day-to-day life are probably, unless you are 100% sure that this is what you need. You don't want to touch the multi-release jars. You don't really want to build images with JLink. Yeah, you can get a little bit less space consumption by your final Java executable, but is it really worth it? Well, the future will show. Another thing not to touch is the unsafe, because it's always a good idea not to touch the unsafe. You are doing a great job on that. And advice how to upgrade to Java 9. Download Java 9, upgrade your IDE, upgrade all the tools that you can, your build tool, your plugins to the build tool, everything. If you're using a web framework, upgrade to the latest versions. Spring 5, for example, when it will be released, allegedly it supports the current state of the things in Java 9 and uses the features of that correctly. The previous 4.3 is current latest release it also supports that and runs with Java 9, but there are some workarounds about that. Ask Jürgen about that. I'm not that expert in that. You want to add the illegal access equals warn, not permit to your process. You want to look at the list of the warnings that it emits. And if you find something that you can potentially fix easily, do it. Strong encapsulation, better security, better platform integrity are good things. Do it. When you do that and you just stuck with things that are not easy to fix, go back to the class path. It's not bad. It's normal. We ran that before. You just have to acknowledge that not always you get what you want to get, and not always it's as easy and at the moment when you just like, I need this now. Well, don't be sad. If you think about this, this is a good release. Java comes forward. It was very important to get the module system out of our way, and we did that, and hopefully the migration path won't be as bad, and which is more important, the migration path to the next versions of Java, like Java 10 and further. Hopefully they will be easier, because currently we will take that hard thing and do it and manage it. We are out of time, so I hope you are excited about Java 9 now. And if you have any questions, or if you want to email me and say how insightful this was, You are welcome. Thank you.